Okay, so in this box we've got the up converters, down converters, GPSDO and various other components. So I'm going to walk you through those, but let's start with the various cables coming in and out of the box. So we've got our uplink and downlink IF connectors there, so they're obviously going to go off to the radio. We've got our LNB and our LO connections going off to the antenna, obviously to the LNB, and the uplink, which is going to go to the 2.4 GHz patch antenna. And then we've got our DC feed in. So because we've got an amplifier in the box, which is going to draw just a little bit too much current, unfortunately we couldn't get away with using a bias T and feeding it via the coax, but never mind. Okay, so in here, let's give you a walkthrough. So in comes our DC, and that in turn is feeding the 12 volt to 28 volt step up transformer, and that is powering the amplifier there, 2.4 GHz amplifier, which should in theory give somewhere in the region of 12 watts PEP, but obviously with the loss on the feeder at 2.4 GHz, it's probably going to be more in the region of 8 watts by the time it gets to the patch feed antenna. So these boxes here, we've got our Upconverter. So that's going to be using 70 SEMS IF, 432 megahertz, and up converting that to 2.4 gigahertz. And then we've got our down converter there. So that's going to be taking our feed from the dish at 10 gigahertz or X band. But that's going to be converted and down converted effectively on the LNB to approximately 739 megahertz, I think. And then the down converter is going to take that IF effectively from the LNB and down convert it again, in this case to 144 megahertz or 2 meters, which is then in turn going to feed back down. I don't remember which one's which. So that's the IF out, top one. Yeah, I believe the one marked orange is the 2 meter IF, but I'll obviously check it before I hitch all this up. So then we've got the GPSDO here, and we've got our GPS antenna connected to it. So effectively what that's going to do is receive and get a fix from GPS satellites, and it's then going to use that to feed a 10 megahertz reference signal to the down converter and the up converter. Now I've opted to do it this way instead of using the internal local oscillators on these two devices, because if the GPS were to drift for any reason, maybe it lost the signal to the satellite or whatever, both the up converter and the down converter should drift in sync as opposed to drifting apart. So that's the reason for doing it. Okay, what else can I show you? There is one consideration here. If I were to power up these three devices at the same time, so the GPSDO and the up converter and the down converter, what would actually happen is the up converter and the down converter would initialize before the GPSDO had a chance to start sending its 10 megahertz reference signal, which means they wouldn't get one and they don't go back and retry. So to get around that, what I've done is put in a small relay circuit here. So basically that's going to take its 12 volt power, 12 volt DC power, and it's got a small delay of about, I've set it up for about 10 seconds. After 10 seconds, it'll then feed power to the up converter and the down converter. But the GPSDO is powered at all times as soon as power is applied. So if we demonstrate that, if I just power this off, at the main PSU there. So you can see everything's gone off. If I power that back up, you'll see that we've got the green light there on the GPSDO, but the relay hasn't yet initialized. There you go. Now, I don't know if you heard that kick in, but we've got the green light there on the downconverter, and also a green light now on the upconverter as well. So there you go. It's a pretty easy workaround. They're only a couple of quid. I mean, the other option is get rid of the GPSDO and just use the internal or local oscillators in the upconverters and upconverter and downconverter. But then you've got the potential for a bit of drift. So it's your call. But you know, that's just doing it with this vendor's kit. If you were to use a different vendor, you might stumble across some slightly different issues. Okay, so that's about it. The next thing to test is the resonance of the patch antenna, patch feed antenna at 2.4 GHz. Not that there's very much I can do to tune it, frankly, but it's just a sanity check. So the theory is that we should be able to measure SWR from the amp, and that's what we'll try. So basically the 2.4 GHz feed here, I'm going to plug that into the patch feed and send a signal on fairly low power, about 3 watts from the transmitter into the upconverter and see what we get out. We've also got a way to measure the power output. So don't quote me, I think it was 4 volts, but I'll check it. So across ground and the forward connection there should equate to full power, which should in theory equate to 12 watts PEP. But we'll see what we get on the meter. Okay, so I'll get this connected up to the dish and to the patch feed, and then we'll come back and see where we get to.
Ja, hier ist wie öfters gibt verschiedene Möglichkeiten. Ich denke mal jetzt bei TX Ton. Faire un mot de passe et puis un compte là-dessus, c'est vrai que c'est la meilleure solution. En ik zeg dat ook al mee. Als wat we vragen naar Uber, die doen dat de mensen gewoon weer op bord genomen. My name is Marco, and thank you for à l'écoute. Je reprends un câblon. est tout en haut de la liste. Et il préconise pour les débutants de commencer par la 0.